everyone, it's Alyssa and welcome to You Can Learn Math. Today is on interest that is compounded continuously. Only that, compounded continuously. If you are looking for regular compound interest, that is ones that are compounded annually, one time a year, or anything that's compounded a little more quickly than that, like quarterly, monthly, daily, links to those are in the description below. I have made videos on those. Again, only compounded continuously. So let's get started. We are going to go into what the formula is, what the pieces of it are, and then how to solve for the different parts of it, how to solve for each of the four variables that is present. And I'm going to put links down below, so if you need to jump forward to one of those, you can just go boop, right to it, right to the variable you're needing help with. Okay, so part one, what is the formula? You may see it written a couple different ways. This is the way that I learned it. A equals P times the constant E to the power of RT. Okay, you may also see it written something like this. It means the same thing. It means the same thing. Same exact formula. So let's go through the pieces and see exactly what these pieces mean. First, we have our A. A is the final amount. How much money is in the bank account after this session of compounding continuously? Then we have P. P is for principal, or the beginning amount. Skipping E for a moment, R is the rate, the percent. T is the time in years. And then lastly, we have E. E is an oddball here in that it's not a variable. It is a constant. This is a famous mathematical constant, kind of like how pi is a famous mathematical constant. So is E. You most likely will have an E button somewhere on your calculator. If you don't, then an approximation of that is that E is 2.71828. Yeah, this was a constant that was named by Euler. Euler begins with an E. There's Euler's number. It was actually discovered prior to that when someone was trying to figure out about compounding interest. They discovered this constant. And the name escapes me at the moment. I believe his name began with a B. I can't remember it. But it is a constant we're going to use. Again, there should be a button on your calculator. Right. So let's get right into how to solve for all these different variables. And I'm not going to erase this. I'm just going to move it up here to the corner so that we can see it while we're doing these problems. The first one we're going to be solving for is the final amount. We're going to go in increasing order of difficulty. So first we have the final amount. We're going to be given everything else. So I am told that the person invested $9,000 into a bank account, and this was compounded continuously at a rate of 5%, and it happened for 12 years. What was the final amount? Well, I'm going to write my formula here, and I'm going to replace one by one, with what I have. And I should have given myself a little more room. Let me space that out. There we go. First, this 9,000, that is the principal. That is my beginning amount, 9,000. E is the constant, and I'm going to use the button on my calculator. I'm not going to substitute the 2.71828. If you need to, that's fine. If you don't have that E button, if you do, just leave it as E for now. Then we have our rate. I'm given the rate as 5%. I'm going to write that as a decimal, 0.05. And we're told how long this was, 12 years. So now I know that A is equal to 9,000 times e to the power of 0.05 times 12. So depending on how your calculator is, there's a couple of ways that you can write this, a couple of ways, that you can input this into your calculator. One way that you can do this is to use a lot of parentheses. So you can enter it as 9,000 times parentheses e to the power of parentheses 0.05 times 12 parentheses equals. And the answer that you get if you enter all that is $16,399.07. Now, one thing, depending on what calculator you have, when you do this little bit, just a little helpful hint, there may be a button on your calculator. For example, on the iPhone, if you have the standard provided calculator, you turn your phone sideways and you get more buttons. There is a button that looks like this, e to the power of x. Don't use that one if you're typing it in left to right exactly like this. It's going to probably give you an error if you do that or something strange. Use the E button, then press the button on your calculator that looks like this, x to the power of y, and then go from there. That's how, depending on the calculator, it may be this little caret or it may be x to the power of y. Okay, so just trying to help, to be able to put this into your calculator correctly. And that really is the hardest thing about this, is just proper calculator usage. The second one is where we're going to solve for the principal. And this is pretty similar. It's not really complicated math. It's more about making sure we do this very precisely in our calculator. So there's a different kind of word problem that they often use with these percent problems that I want to show you. And this is going to be, we're solving for the principal, but note how it's worded. We'll say Betty was investing in an account that compounds continuously, and it's 4.8%. If she wants to have $5,000 in 2.5 years, how much does she need to invest? That question, how much does she need to invest? That's asking you for the principal. It's asking for the beginning amount. So let's fill in what they've given us. They've told us this account has a rate of 4.8%. So I'm going to enter it here as a decimal, 0.048. They've told us that the final amount she wants to have is $5,000. So I put that in for A. And we're also told this was over 2.5 years. So I'm putting that in for time. So what I'm going to do is I'm going to first, to solve for P, this really is a variation of something like saying 10 equals P times 5. I need to divide both sides by 5 and I'll have P. Unfortunately, the 5 in this particular case is a little more complicated, but it is still just a number. So I'm going to enter that number into my calculator. I'm going to press my E button, then my x to the power of y, parentheses, 0.048 times 2.5, close parentheses, and equals, and I get 1.12749. I'm keeping it long. Times P, why did I put equals there? Times P equals 5,000. So now I need to divide both sides by 1.127497. 1.127497. All right, so 5,000 divided by 1.127497 tells me that this person, did I say her name was Betty? I think I did, needs to invest $4,434.60 in order to have $5,000 at the end of 2.5 years. Okay, next one on the list is going to be solving for the rate. And this is where it gets a little tricky. Rate and time both are a little tricky, and they're going to bring in logarithms. I don't know anyone that really loves logarithms. They're not a super popular thing. I'm with you. I totally agree. Not my favorite either. But we got to do it. So we're told that the principal, the initial amount invested, was $2,000. And after 5 years of things being compounded continuously, the account has $2,335.32. What was the rate? Well, A equals P times e to the power of r times t. Well, let's fill in. I'm told the principal, and I never give myself enough space. The principal is $2,000. I'm told the time is 5 years. And the rate is, rate is what we're trying to find. The final amount is $2,335.32. Okay, so the first thing I want to do is I want to get rid of this 2,000, which I can do by dividing both sides by 2,000. So 2,335.32 divided by 2,000 gives me 1.16766. And that equals e to the power of r times 5, or I'm just going to say 5r. Now this is where our logs come in, specifically natural logs. Yeah. If you need help with logs, if you need a refresher, I do have links to videos explaining logarithms that I did earlier. They are in the description below. So here's a quick refresher. If I said 3 to the power of 2 equals 9, and I wanted to write that as a log, I would say log base 3 of 9 equals 2. That's where all the numbers here come into play. It's like 3 to the power of 2 equals 9. That's where they go. But if I type this into a calculator, it can give me 2. If I didn't know what this was and this was x, I can't type that into a calculator and ask, hey, if I have 3 to the power of something and it equals 9, what is it? The computer or calculator will not know how to answer that. I have to write it as a log. So the way we're going to rewrite this, we're going to use this pattern that I showed you over here on the left. So the log base e of 1.16766 equals 5r. Now, log base e is a special log, and it's in your calculator in a special way. Log base e is written as ln, or natural log. That's all that ln means, is it's a log base e. So now I can use my calculator to find this out. In most calculators that are like scientific, not graphing, you type in this part first, the 1.16766, and then you hit your ln button. So if you do that, it will give you the natural log of this, and it is 0.155002. All right, equals 5r. So the last step is going to be dividing both sides by 5. And if I do that, I get it's 0.031, and then there's 0, 0, 0. So this is very solid, 0.031, which means my final answer, my interest rate, was 3.1%. Now, solving for the time, we're going to do in the exact same way, because that time is, if I go back here, that time is right up there in that exponent. It's the same location, so we need to use the same method to solve for it. And that's going to be our last problem here. Let me zoom back in. Come on. Come on. It doesn't like me today. Sometimes computers don't like you. I've learned to live with it. All right, here's our final problem. If I invest $5,000 into an account that compounds continuously at 4.4%, and when I take my money out, I have $5,832.45. How long was my money in there? I want to know the time. How many years? How long was it in there? So let's plug everything in. And I'm going to remember to leave spaces this time. So $5,000, that is my principal. That's what I invested. So I put it in 4P. 4.4% is my rate. So I'm going to write it here. I'm running out of room. There we go. I'm going to write it there in for the rate, and I make sure to write it as a decimal, 0.044. And then I'm told that at the end of this unspecified time, I had this amount of money, so that's going to be my final amount of $5,832.45. Now we are going to do the exact same process that we just did to solve for the rate. Because again, as you see, they're both here in this exponent. So again, first thing, I'm going to divide both sides by 5,000 to get rid of that number, that coefficient. So 5,832.45 divided by 5,000 is 1.16649. This is equal to e to the power of 0.044t. Just like before, I can't use any roots or anything like that. This is in an exponent. I have to use logs. We look over here. Remember our pattern. So this would be as a log base e of 1.16649 is going to be equal to 0.044t. And remember, log base e is a special log, and it is written as Ln, or natural log. So you type in 1.16649, then you hit your natural log button. Again, that's on a scientific calculator, graphing calculator. Hit your Ln first, and then your 1.16649. And you're going to get 0.153999, okay? And this is equal to 0.044t. So my final step here will be to divide both sides by 0.044. And when I do that, I get that t is equal to 3.49998. So that's very clearly 3.5 years. And that's it. Those are your four different, solving for those four different variables. Again, if you're needing help with other compounding interest questions like regular compounding once a year, compounding daily, quarterly, monthly, or if you need help with logarithms, want to brush up on those, links to additional videos are in the description below. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.